In the previous part, we set up a project using the Xtendroid DSL, and we created a simple activity and a layout for that activity. Let's look at how this magic actually works. So Xtend is a transpiler, which means the code gets generated into Java source code. We can have a look at the source code if we go into the build generated source Xtend folder. And here we can see the generated Java source code. So let's have a look at the main activity. In fact, it looks pretty much like a standard activity you would write, apart from some underscores. So there's no real magic here. Xtend just generates Java for you. This makes things a lot simpler, and the speed of execution is the same as if you were writing Java. Okay, so now that we're happy with that, let's go and create a whole new activity. And we're going to create the navigation structure for our application. I like to base my navigation structure using the nav drawer and also using fragments rather than lots and lots of activities. So we're going to create a nav drawer activity, and we'll place all our activities into an activities subfolder or package, and we'll actually make this our launch activity. So let's let Android Studio generate a nav drawer activity for us, and here we see what it looks like. It's created a nav drawer activity together with a floating action button and so on. So we've got a standard Java activity here, and because we're in an activities package, we just need to import the R class. Now everything compiles, and we're ready to convert this into Xtend, which will make everything a lot shorter and simpler. So let's convert this into Xtend, which basically means that the generated Java file will look like what we just saw now anyway. So this is our Xtend file. And because we're using Xtendroid, we can start using our DSL magic. Android Studio has also created some layouts for us, as you can see. First, let's make this our launch activity. So we'll get rid of the intent filter from the main activity, and we'll add it to our nav drawer activity. So this will launch on startup. We can now run this and see what it looks like. Okay, so that's what our generated nav drawer activity looks like. We've got some menu items, a floating action button, and a nav drawer. So let's start adding our Xtendroid DSL to this class. Wherever we see these find view by ID, we can get rid of them, because the Android activity annotation will take care of it for us. So we add the Android activity, and we just point it to our layout. And once we've done this, we can get rid of most of our, in fact all of our find view by IDs. Unfortunately, that dialog keeps popping up, and I haven't quite figured out why. So just bear with me on that one. So instead of overriding onCreate, we can use the @onCreate annotation to tell Xtendroid to run our init method, for example. So we'll just call it init. And then we can get rid of all of these lines of code. And anywhere where it says find view by ID, we can just replace it with the ID that's defined in the layout XML itself. So as you can see, our code is now a lot shorter. And this class looks now quite a lot neater. Great. We can now start adding a fragment. So let's create a whole new package to keep our fragments in, and we'll call it fragments. And let's create a new generic fragment just to get started with. So I'm going to create a new Xtend class called generic fragment. And this is just going to be a placeholder fragment until we start implementing our app. So we'll create a new layout resource for this fragment. We'll call it fragment_generic. This naming structure keeps all of the fragment layouts together. We'll just use the generated layout, And now we can go into our fragment class and we can add our Android fragment annotation, which is pretty much exactly like the Android activity annotation. And you'll notice that this is very simple. The class hasn't even extended a fragment, and the Android fragment annotation automatically adds the extend fragment bit. So now we can go into the method where the user clicks on a navigation drawer item, and we'll default to the generic fragment. So we'll create a new variable called fragment. That's just a new generic fragment. And we will then use the support fragment manager to load that fragment. So this dialog keeps popping up. I'm not quite sure why yet, but hopefully I'll have that sorted out soon. So we can reference our support fragment manager and begin a transaction to load our fragment into some sort of container. We haven't defined that container yet, so let's go and have a look quickly at our content. Let's go and have a look at our content layout and see what our container is. So if we look at content nav drawer, that's our content layout. You can see it's just a relative layout. So it hasn't got an ID. Let's just add an ID. In fact, we shouldn't really be using a relative layout. We should use a frame layout because relative layouts are fairly expensive. They do 2 measurement passes, but we'll change that later. So now we can replace whatever is in the content container that I've just defined with this new fragment that we've created. Now we'll see a compile error on this fragment, and the reason for that is by default the Android fragment annotation extends the built-in fragment, not the support fragment. So let's just tell it rather to use the support fragment. So we can extend the support fragment, and now everything compiles and we should be able to run this. We can also get rid of the find view by layout for the drawer layout. That's even better. So in order to see some change, we need to add something to the fragment. So let's add a text so that when we select an item, we can actually see the text appear. So we'll just use a large text and give it some text. Again, this is just a placeholder fragment, and we'll define new fragments for when we start implementing functionality. So we can run this now. And now when we select any item, generic fragment appears. And this is quite simple. If you look at our code, we have probably the shortest fragment you could probably create. Great. We can also click on other items and they all load new generic fragments, but we can't see any change because there's no animation. So since we're going to be using lots of fragments, we need it to behave somewhat like activities. We need things to appear and disappear. So I'm going to create a new animation resource, and this will be to allow fragments to slide in from the right and slide out to the left and so on, depending on whether they are being revealed or hidden. So I'm going to create the slide in right, for example, and declare it as a translation from a particular x coordinate to another x coordinate, and Android provides us with some nice with a nice tag for that. So we can just create slide in left, slide in right, slide out left, slide out right, and they just basically translates from different x deltas to different x deltas using the decelerate interpolator. Great, so now we can go back to our fragment manager and we can tell it to use these animations by calling the set custom animations method, and then we'll just pass in all of these various animations that we've declared. And this should allow us, this should actually animate all of the fragments in and out. And just to see this all in action, I'm also going to add each fragment to the backstack so that you can reverse through all of these fragments as well. Of course, this is just for demo. In the real application, we don't want the top level items to add to the back stack. So now when we click on any one of these top level items, you can see these fragments animating in, which is fantastic. And then we can also use the back button to animate back out. Okay, so that is basically our app's navigation structure. And in the next part, we can actually start implementing some of our features for the application.